Hey y'all, it's Sarah, and today we are going to be talking about implicit differentiation. I am pretty much just going to be going through examples today. I think that's definitely the easiest way to learn this. So we're given an equation involving both x and y, and so we don't have it just in terms of like f of x equals and then a function only in terms of x, right? We have an equation of two variables. And so what we want to do is we want to find dy dx. So our first step here is going to be to take the derivative with respect to x of both sides. Okay, so d dx of x squared, that's just a regular derivative, right? It becomes 2x. d dx of y squared, that's a little more complicated. Essentially, we're using the chain rule. So what we're going to do is we're taking the derivative of y squared as if y is its own function of x, okay? So we're chaining it. So we bring down the 2 and just have 2y, and then we also have to multiply by the derivative of y with respect to x. So it's sort of like chain rule. And then on the other side, 16 is a constant, so this just becomes 0. And now what we need to do is solve for dy dx. So I'm going to subtract the 2x from both sides. So we have 2y times dy dx equals negative 2x. And then I'll divide both sides by 2y to get that dy dx equals negative 2x divided by 2y. The 2's cancel, and this becomes negative x over y, and that's our derivative. Okay, I'm going to do another slightly more complicated example so that we can really make sure that we've sort of hammered this in. So again, my first step is going to be differentiating both sides with respect to x. Okay, so x cubed, that's only in terms of x, and so we are just going to use power rule. So that just becomes 3x squared. For the y cubed, sort of like with the last problem, we treat it like chain rule, right? So we take the derivative, it becomes 3y squared, but then we also have to multiply by dy dx, right? The derivative of y with respect to x. Now, for the negative xy squared, we are going to have to treat that like product rule, yeah. So I am going to start by taking the derivative of x, that's just 1, so 1 times y squared. And then we also need to take the derivative of y squared and multiply it by x. So derivative of y squared is going to be 2y times dy dx, and we multiply that by x to get 2xy times dy dx. And then the 6 is a constant, so when we take its derivative, it becomes 0. Now, we need to rearrange this to get the dy dx's together so that we can factor them out. And I'm going to move everything else over to the other side. So we have a 3y squared times dy dx, and then minus 2xy times dy dx, plus 3x squared minus y squared equals 0. Now we move these terms over to the other side. We get 3y squared times dy dx minus 2xy times dy dx equals y squared minus 3x squared. Now, on the left-hand side, I'm going to factor out the dy dx from both terms. And now, in order to isolate dy dx, we just divide both sides by 3y squared minus 2xy. and that is going to be my derivative, which we have solved for implicitly. So again, this is going to be very useful whenever you have equations of two variables where, it's not isolated so that we have like y equals and then some function of x. Instead, the x's and the y's are just jumbled together. That's when implicit is really going to come in handy. And keep in mind that a lot of the time you're going to end up with a derivative that involves both x and y, and that's okay. That's just sort of the nature of how these things work. All right. Thanks, y'all. If you enjoyed this video, please like and subscribe.